Welcome to Chem Help ASAP. In this video we will see a classic epoxide opening by a strong nucleophile. The work in this video was reported in an issue of the Journal of Medicinal Chemistry by a team of scientists in the NIDA, National Institute on Drug Abuse, of the NIH, National Institutes of Health, led by Dr. Amy Newman. The citation is on the following slide as well as in the video description. At the top of the screen is our reaction. We start with an epoxide. Epoxides are electrophilic and they are opened by either strong nucleophiles under neutral to basic conditions or weak nucleophiles under acidic conditions. We do not have any strong acids in the reaction, so this is a strong nucleophilic opening. Before starting the mechanism, I'll suggest that we abbreviate these bigger rings as R and R prime groups to streamline our pictures. Okay, our nucleophile is a cyclic amine. This kind of ring with two nitrogens is called a piperazine ring. The nitrogen on the ring is a good nucleophile, good enough to do an SN2 reaction and good enough to open an epoxide. The amine attacks the epoxide at the less substituted side because the nucleophilic amine wants as unhindered a path as possible. We make a new CN bond and break a CO bond to open the ring. Let's draw the outcome of this reaction. There's our O-. Here's our piperazine ring, now included in the molecule, and we have some formal charges. There's our opened intermediate. To finish the reaction, we just need to handle these two charges. I'll focus on the oxygen first. We need to protonate it, and we'll use our solvent, isopropanol, as a weak acid. There is our new alcohol. Here again is the piperazine ring. We'll need a base to deprotonate the nitrogen, and we will use our newly formed isopropoxide to remove that proton. That's it. I do want to address stereochemistry in this reaction. Nucleophilic attack occurred at the end carbon of the epoxide, so the opening has no effect on the stereocenter in our starting epoxide. The oxygen on the middle carbon started back and finishes back in the product. The NIH team prepared this molecule as a precursor to a number of different structures with potential use in the treatment of opioid use disorder, which is unfortunately a widespread condition. One of the most promising compounds, the primary lead from this work, is shown in the lower right corner. You can certainly see how our reaction product forms a large portion of the lead's final framework. At the time of this video's recording, data for the lead are being gathered and reviewed for an IND, Investigational New Drug, application to the U.S. Food and Drug Administration. A successful IND will allow the start of clinical trials, human testing of this molecule as a potential drug. In conclusion, epoxides are fantastically useful for connecting molecules and introducing new functionality. If you are interested in seeing how Dr. Newman's group at the NIH synthesized these potential drugs to treat opioid addiction, then check out the reference. Please subscribe, like, or leave a comment. Take care.